Welcome to the Building Simulation Group 10-year anniversary event, 2009 to 2029. Where will the next 10 years take us? Before I start, just a quick announcement. We will be videoing the presentations tonight, and so obviously at a later date, when they're up on our website, you can share tonight's presentations with your colleagues. So I'm Darren Woolf, I'm the Chair of Building Simulation Group. I'll be giving a brief history of time, well, BSG time, followed by Stephen Lisk, CIBSE President, who will be talking about the future of building simulation, and then followed by Darren Coppins, who is our Vice Chair and the CERT Chair, who will be talking about building simulation certification. So, we're 10 years old.
Hey!
Hey! This is a celebration. And how we've grown. We're almost 13,000 members. We have a steering committee that meets 3 or 4 times a year. We target 2 or 3 maybe seminars over the year. Many publications that we get involved with, and guidance to industry, more of that later. And also one of our, what I think is our key value points, which is about disseminating best practice and the various seminars that we hold with the past presentations that we hold on the website. And you'll be seeing a whole series of slides on that in a bit. So a committee is maybe seen as a sort of abstract entity, but it's really made up of people. And people are the value of the group, and our activities within the committee are actually what makes it successful. So this week, 10 years ago, was the inaugural meeting of the Building Simulation Group. It was chaired by Professor Hazim Awbi, who's still involved in the group, as are a number of others within the list there. So continuity is great, as well as fresh blood that comes to support our group. And so the group is made up of academia, industry, manufacturers, vendors. We've got quite a wide array within the committee. This is what the committee looks like today. Again, we've got academic and industrial and manufacturing and various other partners, and we have the members there, the cooperative members and the executive. And a big thank you goes out to the committee, because it's not only the time that they put into the work of the group, but a thank you to their organisations that release them so that they can spend their time doing these activities. The executive in particular, they get a lot of emails, maybe 10 a day on occasions, close to events, flying around, and we're just putting our thoughts, sharing those thoughts. There's Vasiliki, who's recently joined us on the social media secretary. There's Alex and Nagman, Alex driving the event, so thank you for him for today. Nagman on group secretary, and you'll hear about Darren's activities, vice chair, later. So I looked at the archive of all our past presentations, and from each of our events I wanted to take one slide and share 1 or 2 thoughts on each slide, because we've come quite a way in the last 10 years. And the very first event we had was in 2009, Building Energy Simulation in Practice. And this is one of our favourite topics. It feeds into the compliance modelling side, design modelling side, or modelling of real buildings. And it's a hot topic that is still a work in progress, and how we move forward from this is something that we are having a new conversation in our group, looking at how we may define this optimum process, how we may define what we see as the best way to simulate buildings for performance so that they end up with the best design. So what is the optimum process, and also how we might be able to promote the market so that the best practice in simulation is actually taken up within our projects. Second event in 2009 was the role of CFD in building and system design. So CFD is a very, very powerful tool, and those that use it recognise the limitations as well as the power of the tool. And part of that is understanding how the simulation results should be appropriately interpreted so that your message is on point. And that is the skill of the simulation engineer. It's not just about building models and getting the results out. So this here was 10 years ago, looking at wind and buoyancy, where we've got the outside environment and the inside environment. And we're seeing quite quickly with wind going from left to right that the conditions in the left-hand side of that building are quite different from the conditions in the right-hand side. And even within the simulation, we recognise that physical modelling could support our understanding of these types of simulations. And by the way, when this comes on to our website, there's a direct links at the bottom, but you can go onto our archive area and see all the relevant presentations in each of these themes. Then in 2010, we had an event on natural mixed mode ventilation modelling, and the facade can be extremely complex. The physics of the facade in terms of heat transfer through the 3 heat transfer mechanisms, air transfer, whether it's controlled or uncontrolled, and capturing that within the simulation environment well is still a challenge in some circumstances. Understanding the relationship between pressure differences and flow through complex openings is something that's extremely challenging. Again in 2010 we had an event on computational modelling as low energy technologies in the built environment. And quite often when we use our tools we think of the material, our fabric, as a homogeneous element with fixed properties. But the reality is that buildings aren't homogeneous. This is actually looking at a hydrothermal assessment and showing the variation in conductivity as moisture accumulates. And simulation will be moving towards about understanding the combined performance where you have non-uniformity and non-linearity within our simulations. Again, 2010, there was this event on daylight simulation for design and compliance, and this was one of the early stages of CBDM, climate-based daylight modelling, where again it was about something that came out of academia, a lot more physics, a lot more data, but it's now started to come into the mainstream in particular sectors like schools, and it will keep on being more and more entrenched on that simulation side. And there's a lot of parallels on the lighting side to the thermal and airflow side as well, how we deal with more physics and more data. Then there's particular systems that are quite complicated. This was in 2011, energy storage in buildings, modelling and simulation. And there's this aerogel solar collector, and it was about modelling of the aerogel tron wall, solar heated collector storage wall. So how systems actually come together in the simulation world and how we can model their sensitivities, understand what the likely performance is within a series of ranges and then interpret that so that it leads to good design is something which is another challenge. And I just think it would be a real shame if some of the new technologies that are out there we're not using because building simulation hasn't caught up and actually captured the physics associated within those new systems. So we need to keep pushing on the simulation of these complex systems. 2011, post-occupancy evaluation and dynamic simulation. So this is all about linking modelling to performance in use. There's about claimed performance and then real performance. And there's it's talked about gaps and how we actually bridge these gaps and how we move towards best practice in performance-led design is something which we're promoting within our group. And one of the areas of these gaps, when we had an event on operational energy use and modelling, is profiling. What do we really mean by profiling? Do we sit there and define a certain time where we're going from 0 to 100? Do we decide on what that profile might be? Or do we start to get some real data on how profiles actually work, perhaps for certain types of companies, and start feeding that into the actual simulations so that they start to become more and more realistic? So this is something, again, that is not solved yet. It's something that there are some really good initiatives, such as on TM59 and that profiling, and how we move forward is something that we will still be working with. In 2013, we had designing for better indoor environmental quality of buildings. So this is actually a CFD model of a person, a mannequin within the building. Quite often we treat people as virtual points or volumes in space. Where we will see this going is there'll be feedback mechanisms. There will be the thermoregulatory systems built into maybe virtual people, or maybe something that's actually got a surface defined that is actually radiating to other surfaces and other people. So this is an area, again, where the research we've talked about, and we'll see more and more as the simulations are developed. I quite like this title of this slide, in the design for simulation of zero carbon buildings, because it catches a lot of what I think simulation's about. It's dynamic. It changes over day, over season, and it's about simulation experiments. How can we actually design, like you do for a design of experiments on the physical side, how will you design your experiments on the computational side? And this is actually building in some of the sensor monitored data into the simulation data, and seeing how that improves our understanding of building performance. So in 2014, we were modelling air movement, CFD simulation versus experimental methods. So anyone in the simulation world recognises it's just a model, it's a representation of reality. There's no such thing as an accurate model. There are uncertainties, tolerances, both on the physical and the computational side. And when we start to see some of these major bits of research, like the DAPL dispersion project, where they're tying in wind tunnel results with CFD results, looking at the impact of turbulence or RANs against some of the higher order large eddy simulation modelling, it's all great for our industry, because there's always thrown, how do you know those simulation results are accurate? Quite often we don't get a chance to validate, but it's about best practice in use for simulation, which is what drives our industry forward. 2014, we had advances in building simulation. This was a shared day with CIBSE, and this is something we're going to see a lot more of. I think this will really start to change the way that we simulate, and it's parametric optimization. The word Pareto front is something that will come more and more into our simulations, and the way I see it is, currently you may have tens of simulations for a particular project. We're moving towards thousands. And as engineers, we will be not designing, okay, that's a flow rate, fix it, that temperature, see how it performs. We'll be looking at our equipment, putting the sort of ranges of flow rates and performance into our models. And so we'll be designing the constraints and looking at for a whole series of ranges of different drivers, which might be orientation, shading, mass, whatever we're wanting to look at, we'll be looking to see how that drives the design forward. And this is looking at cost versus carbon, which is something that you may not see often, but we will be seeing that more and more often. In 2015, we looked at building simulation. Are university graduates ready? So this was an interesting event where we were trying to look at the skills of graduates as they come into industry. As you can imagine, that there's so many tools out there that it was almost like being in a sweet shop. Where do I go as a graduate, and where does my career go? I quite like that line there. Simulation's role is to support multivariate assessment and deliver experiential outputs to aid understanding. So it's about a graduate experimenting with the tools, looking at multiple tools and seeing how that, through as they learn within the industry, how that may actually guide the designs. So it's less driven by output says this, so the design should be something. It's about how their skills can actually drive the design forward as part of a design team. Linking building design performance with BIM. So one of the things I love about building simulation is that we've not cracked it. We are so far away from cracking it, and we will not do it within my lifetime. We can look at room scale to building scale to community scale to urban scale, and the physics are extremely can be easy, can be extremely complicated. But when you've got dependent systems, we'll start to see them coming together a lot more often, and less of this silo looking at different systems and different specialist skills. But that will all be coming together when they're dependent, and we'll see that within the simulation environment. So when I said it's difficult, we know that turbulence is extremely difficult. So quite often when we do CFD studies, we use what we're seeing on the top, which is a steady state Reynolds average Navier-Stokes type solution, where it's an averaged field that we're generating. And below is the large eddy simulation, which is a transient solution, but it's not just stepping in time, it's actually catching some of the larger scale turbulence within the simulations, and these tend to run into the tens of millions of elements within the models. But with the onset of our computing revolution, where before it was about the computer size that drove where you went in simulation, that's becoming less of an issue now. It's about more physics leads to more understanding, and the computer can deal with it. It's becoming far, far more accessible. In 2016, we launched our key document, the Building Performance Modelling, AM11, and this was split into a number of chapters that you can see there. But the key thing about this is that it took us 5 years to write, and there was the best minds, or some of the best minds in building simulation, that put it together. And this is going to be the guiding light for how we move forward with best practice in building performance modelling. And I shan't steal Darren's thunder, because he's going to be talking a little bit more about how that is actually moving forward. 2016, we had an event on simulation for health and well-being, and there's all sorts of different areas that people are looking. Circadian lighting, air quality is becoming more and more built into our thinking. Why was it just hospitals and schools? Why isn't it everything that we're doing air quality? Because that impacts productivity. And what I liked about this slide is that it starts to talk about mortality, urban heat island, and indoor temperature. So at some point in the future, what would we do in terms of the way we design buildings if we had different metrics, such as mental health, such as morbidity, rather than a temperature that we're trying to target? So there are some indexes that we are starting to come through, and the health and well-being agenda, as well as the performance agenda, is something that will be driving us forward. Then there was this overheating risk simulation methodologies for buildings. So we recognise that this is a CFD study that's integrated in with a dynamic thermal modelling study, and there's strengths and weaknesses of both in terms of spatial and temporal resolutions and how they deal with that, and in terms of the physics that they capture. But it's about not just individual tools, but how the tools work together and how we use that in order to drive our designs in a positive way. One of our favourite topics, building compliance versus performance. There was a lot of press a year or so ago, which was maybe not as aligned as it should have been. Maybe it didn't recognise the differences that are inherent between compliance modelling and what we would see as best practice performance modelling. And as an industry, there's some excellent initiatives coming forward, like Design for Performance, and they're being more and more used across the industry. But we are looking again towards how we can define what is the best practice for using simulation to design our buildings across all the various contexts. Last year we had a talk on hacking simulation, and so this was again recognising that some people go off-grid. You know, it's not just about using a tool, it's about what you can do to increase value in what you're doing. And geometry is still a work in progress, and you've got many different tools across different disciplines, and how we start to share that geometry across different disciplines, and how we start building in some of the complex systems, HVAC systems and their performance and controls, is something that we tackled in this event. Finally, there was the event last year, Build to Perform. We had a number of different activities there. It's captured in this blog that we've got, CIBSEBSG.blogspot.com. All the videos are now up there, and again our social media, thank you Vasiliki, have been Twitter and LinkedIn. They've been quite active announcing that recently, so do join up to our various social media initiatives. And that was a fantastic event, and we are looking forward to Build to Perform later this year. So now I'll pass on to Stephen.
Thank you very much, Darren. Good evening, ladies and gentlemen. I'm a little analogue here, so I still have a notebook where everybody else is off computers and what have you, so I hope you'll excuse that. The first thing I'd like to say is a huge thank you to the BSG team. I mean, you have seen from that history the huge amount of work, and AM11 and the work that entailed was no small task. So if again, I would just ask you maybe just to give a round of applause to the BSG team. So it's a real pleasure to be asked to speak to you, I have to say. As a lighter, I am not an expert in simulation. But my background is to calculate lighting, to determine visual comfort. And actually, when you start thinking about a boundaryless way of looking at simulation, things like circadian lighting, things like day lighting and the relationships to our facades team all start to be more than just a measurement tool, and I'd like to talk a little bit about that later. So if you were expecting a talk on the future of Energy Plus or ESP, then unfortunately you've picked the wrong guy tonight. But what I have done as CIBSE President is focused on change and focused on our profession and our institution, and also the wider engineering profession. So if you're after somebody who can take a look ahead over the next few years and stick with me while I identify some of what I think are the key challenges for our sector, the challenges that the built environment faces and the challenges our professionals and professional disciplines are facing, I think there could be something to offer. So over the past year I've been talking a lot about change, and I've been talking a lot about the pace of change. And one of the things that really interests me is how we communicate change. And I saw a cartoon, which I really liked, which in the first slide had a speaker standing at a lectern like I'm doing tonight. And he asks his audience, who wants change? And every hand enthusiastically goes up because everybody wants change. So our speaker presses on and says, who wants to change? And suddenly there's a little bit of uncomfortable, there's looking away, and there's a little bit of shuffling of feet. But our speaker is not deterred by that and pushes on. And our speaker then asks the third question, is who wants to lead change? And when he looked back up from his notepad, the room is empty. Now, the fact that you guys are still here, I really want to thank you, and I want to thank you for your personal commitment in leading change. Professor Stephen Hawking said that intelligence is the ability to adapt to change. And I think in that aspect, we all get a feeling that the times they are changing. Now, of course, the other genius is Bob Dylan, who wrote that in 1964, and actually at the time, it was a real anthem to change. Now, I think everybody here tonight, there would be nobody disagreeing with me that we are in a period of immense change. And I've promised tonight, you'd be happy to hear no B word, okay? So that's just not going to happen. But what I can talk about is a number of global challenges that we are facing. And the first one, of course, is our climate. I think anybody who's been watching Blue Planet would have been horrified by some of the images of plastics in our oceans. Certainly when we look at the effects of our changing climate, they're evident, and it is evident that we have a responsibility in that. In terms of the 2015 Paris Climate Agreement, it set out a vision of what was to be a low-carbon, climate-resilient and sustainable future for all. And I think individual countries have committed to, by mid-century, having strategies that address these issues. The key thing, I think, we would all agree, is how these are actually implemented. Given the fact that we have got record levels of cost in terms of floods and monsoons and other natural disasters. 2016 was the hottest year on record, and we know that the climate is warming up, with temperatures 1.5% above pre-industrial levels. And that increases the pressure for change in the built environment even further. And that takes us on to the bit that we can influence. So when I said who wants to change and who is leading change, it is the people in this room. And be in no doubt that construction is under real pressure to change. The WEF, the World Economic Forum report on the future of construction, said that actually labour productivity has stagnated or decreased over the last 50 years. And the WEF report sets out 6 key challenges to deliver better outcomes for the future of construction. You know, I'm just going to run through them real quick because I think they are self-evident. Project delivery, life cycle performance, sustainability, affordability. I've already spoken about disaster resilience, flexibility, livability, and well-being. So I think in terms of the WEF identifying the role of the importance of digital technologies in addressing these, it is wider, as you know, than just through BIM. It is data analytical technologies, and it is technologies that really now will drive the sector, embedding sensors, self-automated technologies, drones, tracking technologies. And I think in terms of actually being able to push these technologies, we need to, of course, be mindful of cybersecurity concerns. And I'm pleased that CIBSE has recently published guidance in this area, and I think that will be seeing digital technologies as more than just as a design model, but looking at actually understanding how it impacts in terms of the life cycle of buildings. And I was really interested in Dame Judith Hackett's phraseology around Grenfell Tower, and a tragedy where people have lost their lives and people injured, and a terrible set of circumstances. But when Dame Judith talks about the golden thread of information, that sits fairly and squarely in terms of a digital technology. So where does that leave us? Well, I can take you through these pretty quickly, because there are a number of things that we all know about. Modularisation. We hear every day about smart cities. We hear about clean energy and smart grids, about buildings as power stations. And boy, oh boy, I hear pretty much a conversation every day in our lighting practice about health and well-being concerns. But how many of these cliches do we want? I think in terms of, Darren mentioned earlier, the growth of computing capability means that computers are doing far more than when the BSG was formed. Moore's law tells us that that will be an exponential adjustment and improvement. And all of these cliche-ridden initiatives are going to demand even more simulation capability and modelling of buildings. Not just modelling the characteristics that we are used to now, but the characteristics that we are exploring and developing into the future. Going back to Dame Judith Hackett and her review into building regulations, it called for, it was slightly underplayed, I think it's fair to say, but it did call for the use of digitisation to deliver more accurate building information in terms of being able to understand this golden thread of information from the design, the building, the maintenance, the operation, and the handover of the building. And that demands change in our industry for greater competence and the means of recognising that competence. So it gives me great pleasure tonight to announce the renamed award for us as an industry to recognise and celebrate building simulation as the CIBSE Building Simulation Award, which will be presented at Build to Perform Live. And I would encourage anybody to, thank you very much indeed, Alex. I encourage you all to come along and take part in that. It gives me great pleasure now to introduce Darren Coppins. Darren's the Vice Chair, to talk about the work being done to start to deliver a scheme to recognise competence in building simulation. Darren, over to you.
Well, I think I've got something to follow there, actually, so yeah, goodness me. I'm Darren Coppins, not the President. There we go. I'm Darren Coppins, and I'm Vice Chair of the Building Simulation Group, and also Chair of what we call the Certification Committee. And essentially, I don't know whether there's anyone in this room that disagrees with this, but considering what we've heard tonight, we certainly are sort of at the forefront now in terms of what we can do with buildings, what we can prove works, what we can prove doesn't work, and actually the responsibilities that we have to improve the built environment as building modellers. And so a few years ago we were sort of talking about certification and training and what's available in the industry. And when you consider that aspects that have come along in terms of Part L has always followed up with some form of certification scheme like the LCEA, and essentially, there's nothing really other than that in terms of building simulation that we can do. We are essentially running, almost running free, but it's our experience and it's our knowledge that's making sure that we get this right. And so we started to look at actually what we should be doing. Is there a gap that we should be filling? And we've been talking about this as a group for probably longer than we should have done before we started to actually get stuff underway. But in October last year, we sent out a survey to all of the members. I think it was about 10,000 back then, wasn't it? Something like that. And essentially we asked them a few key questions. I'm only going to present a few of the questions and the results today, but the first one, quite importantly, do you use building performance modelling in your job? 84% said yes, so we're on to a good start. And then, do you think the quality of professional building performance modelling needs to be improved? And this is sort of where we was getting a bit of feedback in terms of, should we be doing this? Should we not? Are we going to make enemies of everybody? And actually 77% said yes, it does need to be improved. And then we asked, would you be interested in a new building performance modelling certification to assist in improving your competency? And again, 70% said yes, but only 9% said no. So that was actually more than we thought, because we don't want to start alienating, we don't want to put obstacles in place that will effectively stop you from doing your job. And so we then went on to do a Build to Perform workshop last November, where I think some of you in the room actually came to and contributed to, and that was great. We had our first challenge in that we was doing a workshop with headphones. Okay, we weren't quite expecting that, but we made it work. You can see me struggling there with the headphones. And essentially we just did the talking part with headphones, took the headphones off, and then we convened into 3 groups where we went through all of the questions that we decided to ask. And so, because we were quite limited with time, we only had an hour, we sort of started off with question 1 and then moved on to question 2 and question 3, and the group split up and started doing their own questions. But there was actually desire to carry on. So we actually overran by 30 minutes. The energy in the room was just so vibrant. Everybody just wanted to answer all the questions and get their opinions across, which was actually fantastic. There was so much energy in that room that day. I'm not going to go through all of the answers to these, but suffice to say that we've taken that information and essentially we've come up with a 3-tiered approach to what we're going to do. And it's only through volunteers that this is happening, so it's only you guys out there that are basically helping us to do this work. And so the first one is training. And effectively what we're doing is we're translating AM11. I'm not suggesting it needs translating, but we're translating it into online training modules, so that effectively you can go to the CIBSE website, go onto a training module, you can go through one of the chapters. So for example, if you're on LCEA, you can then look at the thermal environmental modelling or CFD and get some knowledge and understanding about what it's all about, get a CPD certificate so that you've shown that you've got a basic level of knowledge to be able to continue with widening your abilities. And then we're going to move on to a basic level of certification, an advanced certification. And really the advanced certification is for those that really want to prove their knowledge. It's something to aim for, it's something to be proud of, and that's what we're trying to get to. We are, as building modellers, I know I am certainly, and a lot of people I know are actually really proud about the hard work that we put into it, and we want to be able to get something for it and get some recognition. I really think now is the opportunity to shape our future. With everything that Stephen just said and Darren earlier, this is what we should be doing now. We should be shaping the way regulation looks in what we do as practitioners, because I know for a fact, having started this process, government are looking at it. They're looking at what needs to be in place for thermal comfort. And so I'm talking to them about what we're doing, and maybe possibly we might be able to impart on some of that. And also there are other groups, both in the UK and nationally, looking at certification for what we do. And I'm meeting with them to discuss how we collaborate and that sort of stuff. So if we don't do it, somebody else will. So I think it's really important actually that we pull our resources together and get this as right as we possibly can to make basically our built environment better. Okay, thank you. I'll just pass you back to Darren.
Thank you. So obviously thank you, Darren, for that talk, and thank you, Stephen. Can I actually invite you back up here again? Normally when someone gives a keynote they might get a bottle of wine or something like that, but I actually researched and found some new lighting technology that you may or may not be aware of. It's a colour changing glitter lamp. Thank you very much.
What a thoughtful gift.
So I now invite you to have a drink. We've got some nibbles. Please use this opportunity to network, talk to people, and I think we have till 7:30, so enjoy. Thanks.